TechInFive.
Python in practice. Master real-world projects in 5 minutes. Master multiple regression and its impact on outcomes. Expand your linear regression skills with real-world data. Welcome back to our machine learning series. Today, we're diving into multiple regression, a powerful extension of the simple linear regression model we explored previously. Multiple regression allows us to account for and analyze the influence of multiple independent variables simultaneously on a dependent variable. This capability is crucial in real-world scenarios, where outcomes are typically affected by more than one factor. It introduces a level of complexity that enhances our analytical capabilities in several ways. Capture data nuances, adjust for confounders, and increase predictive accuracy. In multiple regression, the model's equation extends the simple linear regression equation to include several independent variables. Where y is the dependent variable, x1, x2, xn are the independent variables. Beta 0 is the intercept. Beta 1, beta 2, beta n are the coefficients of the independent variables, and epsilon is the error term. Each coefficient represents the change in the dependent variable for one unit change in the corresponding independent variable. This technique enriches our analytical capability, making it indispensable in fields such as economics, medicine, and social sciences, where multiple factors affect outcomes simultaneously. In this video, we will continue using the California housing dataset, which we explored in our previous video on simple linear regression. This dataset is particularly suited for multiple regression analysis because it contains various features that influence housing prices across California districts. Let's first take a hands-on look at the data to understand its structure and the distributions of individual features. We will use the head and describe functions in our Jupyter Notebook to get a snapshot of the data and generate descriptive statistics. Let's see what the data tells us. Median income of households within a block group. This is a key predictor, as income levels typically correlate strongly with housing prices. Age of the house in years. Older homes might have different valuations depending on their condition and historical value. Average number of rooms per household, indicating house size and space, which can affect price. Average number of bedrooms per household. More bedrooms can increase a home's appeal to larger families. Total number of people residing within a block. Higher populations can imply denser living areas. Average number of occupants per household, which might affect the wear and tear on the home and infrastructure. Understanding these variables will help us build a comprehensive multiple regression model that predicts housing prices based on a blend of socioeconomic and demographic factors. Now, we select a few key features that we believe will be predictive of the median house value. For our example, let's use median income, house age, average rooms, and population as our predictors. Next, we need to split our dataset into training and testing sets. This is crucial for testing the performance of our model on unseen data. With our data prepared, we can now create and train our multiple regression model. We'll use scikit-learn's linear regression class. After training the model, we use it to make predictions on the test set. We'll also plot these predictions against the actual values to visualize how well our model is performing. This scatter plot helps us visually assess the accuracy of our predictions against the actual values. Ideally, you want the points to align closely with the red line, which represents perfect prediction accuracy. Now, let's evaluate the performance of our multiple regression model to understand its effectiveness. We'll use two common metrics, R-squared and mean squared error. Mean squared error provides a measure of how close a regression line is to a set of points. These distances are the errors. R-squared measures the proportion of variance in the dependent variable that is predictable from the independent variables. It provides an indication of how well unseen samples are likely to be predicted by the model. Thank you for joining this tutorial on multiple regression. Keep exploring, keep learning, and don't hesitate to dive deeper into the rich field of machine learning. See you in the next video.
Stay tuned for more videos on TechInFive.